introduce you once again to DOSTAS, the Department of Ship Technology Alumni Society, which has been registered as an alumni association of the Department of Ship Technology, Kochi University. Under the Travancore Cochin Literary, Scientific, Charitable Societies Registration Act 1955. DOSTAS is pleased to announce the first edition of the DOSTAS International Maritime Seminar, DIMS 2018, of which you are all a part. It's an international seminar on developments in offshore, shipbuilding, transport and allied sectors being held today and tomorrow. Together, eminent speakers and scholars engaged in the maritime sector from India and around the world. This will be a benchmark event for the alumni as well as the Department of Ship Technology QSAT to establish itself globally. This two-day seminar will provide a healthy environment to exchange information, showcase technical innovations, explore collaborations, and solicit business opportunities. DIMS 2018 will have 17 technical papers focused on latest innovations in maritime sector and will see a gathering of over 500 delegates representing various stakeholders and shipping and offshore industry. Ladies and gentlemen, welcome back. Before we start, it would be prudent for me to explain the pattern of the conduct of the seminar sessions. Each session would be coordinated by a session coordinator who is a subject matter expert in the field being discussed. There would be 4 to 5 papers being presented in each session. Each paper being presented is going to be for a time duration of 20 minutes. I repeat for the delegates, each paper being presented is going to be for a duration of 20 minutes. There will be a short buzzer after the completion of 15 minutes. The next buzzer would be at the 19th minute, indicating that the speakers conclude the presentation prior to the final buzzer on the 20th minute. I request all the speakers to kindly stick to the time duration of 20 minutes. There will be no question answer session at the end of individual presentations. I repeat, there will be no question answer session at the end of individual presentation. The Q&A will be conducted at the end of the final presentation for a duration of 25 minutes. The Q&A session will be at the end of the final presentation for a duration of 25 minutes. Just so I'm clear, the question answer session will be at the end of all the presentations, and all the speakers would be on the dais to answer to queries being posed by the audience. Ladies and gentlemen, may I now introduce our first coordinator for the session on green technology. He started his career in the design department of Corporate Shipyard, Calcutta, after graduating in naval architecture and shipbuilding from Cochin University in 1994. Later in 1997, he joined Alan R. Conroy and Partners, a distinguished marine and oil and gas consultant in Dubai. In 2005, he joined BCTQ Consultants and became the general manager looking after their business in the Middle East region. He became part of the Great Waters Maritime, another UAE-based maritime offshore oil and gas consultancy during 2012. Great Waters now operates from Dubai, Abu Dhabi, Baku, Mumbai, and Glasgow. He's a chartered engineer, a fellow of the Royal Institute of Naval Architects, fellow of Society of Naval Architects and Marine Engineers, NAMI, and member of International Institute of Marine. He is also the chairman of RENA UAE branch and a member of RENA UK Council. He has vast experience in design and project management of offshore structures, mobile offshore drilling units, jack-up barges, crane vessels, FSOs, FPSOs, tankers, and various ship types. He is a Panama accredited marine surveyor and is also a technical committee member of American Bureau of Shipping, Middle East and Southeast Asia, as well as Mobile Offshore Drilling Unit Special Committee under the ABS Houston. Ladies and gentlemen, let's put our hands together to welcome Mr. Ashik Subhani, Managing Director, Great Waters Maritime, Dubai, onto the stage, please.
Good morning, ladies and gentlemen. Green ship technology is one of the widely discussed topic in maritime sector. Whether it's a ship owner, shipbuilder, designer, classification society, or even the port authorities or port operators, everyone is aware of the environment and they wanted to protect the environment by implementing green ship technology into their assets. This is what we are exactly going to hear in the next 2 hours. We have a great lineup of speakers that includes 4 experts and 1 student. We have to hear not only from the experts, but also we have to hear from students. They will have a lot of fresh thoughts and ideas. One thing I can confidently say that this session is going to be extremely informative, and it's going to enhance our technical knowledge related to green ship technology. Once again, I welcome you to the first session of DIMS, Green Ship Technology. The first topic which you are going to hear, that's about green ship technology, present and future. It is getting presented by a representative for the whole classification society industry, for the whole classification societies. He is currently the regional manager for Class NK South Asia based in Mumbai. And one of his great contribution is related to the common IX common structural rules, in which he was leading the common structural rule development from Class NK side. He received a lot of medals, including Singapore Joint Rina and Demarest Branch Award in 2004, and he also received Stanley Gray Medal of Imarest in 2005. He has published a lot of papers in so many journals. He is a chartered engineer. He is a fellow of Institute of Marine Engineering of Science and Technology, Imarest, and he is also a fellow of Royal Institute of Naval Architects. That is Dr. Abdul Rahim. Dr. Abdul Rahim, please welcome you to the stage, and we are ready to hear from you. Please come.
Thank you, Coordinator. Good morning, ladies and gentlemen. I am Rahim from Class NK, and today I'll be talking to you about green ship technology, the present and future. And most of my presentation is based on the research that has been carried out in Japan in collaboration with our industry partners in Japan and around the world. And initially I will talk about the National Green Ship Gas Reduction Program. There are two phases. The first phase ended in 2013. Our target was to reduce the greenhouse gas emission by 30%. There's 22 projects, and we have developed quite a number of technologies, some of them like new engines, advanced low friction paint, hybrid turbocharger, air lubrication, and so on and so forth. And then we have the phase 2 of the project, and the target is about to reduce the greenhouse gas emission by 50%. And 19 R&D projects are ongoing. It will come to an end by the end of this year. It is being coordinated by the Japanese Ministry of Land, Infrastructure and Transport. And today I'll be concentrating on these 6 topics mainly: improvement of optimal hull form, reduction of hull friction, improvement of propeller efficiency, engine efficiency, then waste heat recovery, and utilization of renewable energy. And the first I want to introduce the reduced surface area propeller and reduced non-hub vortex. As you can see here in the improvement, the hub vortex is reduced, and this could result in a saving of 3% fuel. Next one is the contra-rotating propellers, which could actually reduce the fuel's consumption by 13%. These technologies we have already applied on ships, and I'll come to that later. Then we have the air lubrication system. You may have already heard about it. It's very simple. You are pumping air bubbles under the bottom of the ship, so which actually reduces the friction, and it could save up to 10% saving in fuel. It is most effective on wide-bodied shallow draft vessels. The first vessel it was applied is MV Maritime. That is about 6-7 years ago. Now we have introduced this system in quite a number of ships built by Mitsubishi and some other shipyards. And some of the notable ones are the cruise liners for Ida Cruise in Germany. Then the hybrid power system. Here we are using the photovoltaic power generation and storing in nickel hydride battery. As you can see the battery on the top photo that comes near the funnel. This is the first ship called Origa Leader, which has been fitted with this in 2008. So ever since this ship we have been using to study the effect of the hybrid power, and quite a ships coming out recently all have photovoltaic, the photovoltaic panels on board, and it is creating electricity for the use of ships. And next one is the low friction paint. As you can see on the left side, the conventional paints, they have the small micro serrations, which is adding on to the resistance. And if you go to the extreme right one, what we have done is we have developed technologies to smoothen the surface of the paint. This is actually the micro paint surface, and also we have improved the water trap within this so that you'll get a smooth flow, thereby reducing for a VLCC up to 10% of fuel. This has already been applied to more than 700 vessels, and the technology is we just borrowed from the fish tuna. It can go in the water very fast because it has hydrogen in its body. It makes the surface smooth. So we have put the same thing, hydrogen, in these paints, and thus this paint was possible. And the next one, the technology need not be simple. It need not be complicated. It can be very simple. As you can see, called the step spray tearing plate. You can see a small plate fitted in the bow of the ship. It's about 8 tons in weight, and is effective for waves of more than say 2 meter height, and this actually could reduce the fuel consumption by 3%. We have tested it out on the car carrier. You can see there 2 on the top right. Both were delivered in a span of 2 months, one with and one without, and they are both in the same Asia-Europe route, so we could clearly compare it, and we could observe a 3% reduction in fuel. Now it's a hybrid tugboat. This is the Japan's first hybrid tugboat, and this is the schematics of that. What we are doing is we are using the generators to produce electricity, and it is stored in lithium-ion batteries, and then use it as and when necessary. And this is the actual tugboat. It could actually reduce the fuel consumption by 20%. And when it is in the port, it can use shore power, so it doesn't have to run the generators. And next one is the fuel emulsion. That is, we are putting water in the fuel so that you could reduce the NOx generation. Because as you can see in the middle, for medium and low speed engines, the reaction temperature is 2400 K. If we can reduce that to 2200 K, then we can reduce the NOx by 90% or more than 90%. So we can drastically reduce the NOx emission by adding water onto fuel. And this technology has also been applied in a Ro-Ro carrier and a series of car carriers. I will come to that later. And this is some of the results. As you can see, the gas oil, its NOx at the bottom is 263 ppm. And if you mix it with water on the right 2 columns, it can be reduced to less than 9, and that's a 90%. That is up to 14 if the mixture is 44:56. That's the right combination of gas oil and water combination. The next one is a power assisted sail, and this particular thing is applicable for tankers. So we have developed a hard sail as a prototype, and simulation tests were carried out on a 45,000 gross ton tanker. The result shown here is a Tokyo-Seattle voyage in early April departure, because the wind pattern is very conducive for that. And you can see with the power of the sail, So we could actually save about 3% fuel on this one. We also tried from Tokyo to Adelaide all the way down south, but it was not so promising because the wind patterns were not that conducive, so we could get only about 1.5% reduction in fuel consumption. So with this one, we actually confirmed the operationability, durability, and the possibility to reduce CO2 emission. Yeah. And so far, we have been using the designing approach. That is, you change the propeller to narrow blade or rake or whatever thing. But what we have thought of is to go for a new material, that is a carbon fiber reinforced plastic. So it was this first propeller of 2-meter diameter was fitted on a ship called Taitomaru. It's a bunker tanker, and we could reduce the fuel consumption by 6%. Then we have, but this was done about 6-7 years ago. Then we have developed another one for a 28,000 bulk carrier, where we could even get to 7% reduction in fuel consumption. Now we are working on a much bigger propeller, 8-meter diameter propeller for a Panamax bulk carrier. And the most interesting thing is for this particular propeller shown here, you won't believe each blade is only 48 kilograms. So if there is any problem with one blade, you just take it out, put a new blade, and you don't need a chain or pulley because it's only 48 kilos. 2 people can easily lift it and put it on. And the next one is a hybrid turbocharger. What we have done is we have developed a high-speed generator combined with a turbocharger, so that for normal ship operations, you don't need to run all the generators. It can provide power. Thereby, we can reduce the fuel consumption by 3%. And the biggest advantage is, and the biggest advantage is the generator is so small, it's only about 30 centimeter long. So it can easily fit in, as you can see here on the red circle on the right side. So that is what the generator is. So this could actually save the fuel consumption by 3%. The next one is technologies for carbon dioxide and NOx reduction simultaneously. Normally, if you reduce CO2, the NOx goes up, and if you reduce NOx, CO2 goes up. So what we have done is we have beautifully integrated different systems so that we can reduce both carbon dioxide and NOx simultaneously. And one is to combine the water emulsified fuel supply system and the turbocharger cutout system in order to reduce CO2 emission, and use the EGR system to reduce NOx emission. This has been applied on a pure car and truck carrier. I will come to that later. And this is an example of exhaust heat recycling using a turbo hydraulic system which could save fuel by 4%. Here, along with the turbocharger unit, we have put a hydraulic pump which actually pumps the hydraulic fluid into a hydraulic motor which is connected to the main shaft, thereby saving power. So this could actually save the fuel consumption by 4%. And now I am showing some of the designs. This is an eco design come out with Japan Marine United. I'm sorry, this is the previous exhaust heat recycling system I was mentioning. And so this is the eco design developed by JMU. It's a 13,000 TEU container ship. They could achieve 30% reduction in greenhouse gas emission by integrating some of the technologies. One is 21% reduction by improving the propulsive performance. You can see the twin keg hull form, then the forward bridge and the front bonnet, and rudder bulb, and then low friction coating and tip brake propeller. And another 10% by introducing electronically controlled diesel engine and variable nozzle turbocharger and waste heat recovery system. And by using the photovoltaic cell, another 1%. So totally they could reduce the fuel consumption by 30%. This is yet another container ship that came out from Mitsubishi Heavy Industries. There they are saving total fuel by about 35%. 10% using the air lubrication system, then another 24% by hull form and arrangement, and another 5% by having an electronically controlled main engine and heat recovery system. And this is one typical example of a Cape-sized bulk carrier, where they put several technologies, including the ledge bow, that is without, So this is the Mitsubishi one, and this is the one that I'm currently talking about. It's a ledge bow, as you can see bottom right. That's no bulbous bow, it's a straight ledge bow, and we are using the super stream duct as well as surf bulb. So this, with all these introductions, it could save fuel by 20%. That's about 10 tons per day. And these ships were already delivered since 2014, and quite a number of ships were delivered. And this is the 7,500 unit pure car and truck carrier. It's a part of the Drive Green project. 7 series of ships are being built. The first ship was delivered in February last year, and already 3 ships are running between Far East and Europe. Here we could reduce the greenhouse gas emission by, CO2 by 25%, NOx by 50%, and SOx by 90%. And this is the latest of the eco ship that is being delivered from Japan, and it uses the exhaust gas recirculation and water emulsion and a turbocharger cutout system and a bulb fin at the aft, then low friction paint, then the front bonnet for low wind resistance, then it has a series of solar panels on the deck and a SOx scrubber. And yet another concept that we developed is a non-ballast water ship. That's a ship which need not use ballast water. Why we use ballast water is because on the empty voyage, we need to have sufficient water to immerse the propeller. So if you change the shape of the ship from flat to a raked one, you get enough propeller immersion so that you don't need to do ballast. We have developed this design for a very large crude carrier, but of course the cost is a little high and there were no takers. So I'm sorry, I'm sorry for the, problem with the transition. And the next one is a minimal ballast water ship that we did, because here what we did is we reduced the ballast requirement to 25% of the actual requirement. So you can put a small ballast water treatment system on board. So these are the midship section of this type of ships, rather than the green non-ballast water ship where operational problems might occur. So we are using the minimal ballast water ship. Of course, this also currently has no takers. The design is ready, but its cost is high. Next, let me go to the second part of my presentation. Now, hydrogen. It is the most environment-friendly fuel available in the world, because if you burn it, what you get is pure water. But in countries like Japan, it's prohibitively expensive to produce hydrogen. So what we do is, we do it in countries like Australia, where for more than 300 days you have the sunshine and you have a lot of wind, so wind power can be used. So it's all available free actually, so we can produce the hydrogen, then transport it to Japan. But transporting this is a big problem, because liquid hydrogen, the temperature is minus 253 degrees. That is very close to absolute zero. But we have the technology to transport LNG, which is 173, 176 degrees. So if we can mitigate the risk, to see that the risk associated with transporting liquid hydrogen at minus 253 is as good as that of LNG carrier, we can easily transport liquid hydrogen. So that is what we are trying to do. And 2 years ago in Japan, the HYSTRA Association was formed. It's a CO2-free hydrogen energy supply chain technology research association. And then we have another front-end engineering design project where Shell, Kawasaki, then the Japanese Marine Systems, National Maritime Research Institute of Japan, and we are participating. The problem with liquid hydrogen carriers is there is no rule based on which we can design it, because the IGC code applies only to LNG or LPG. It is not applicable for liquid hydrogen carriers. And it's a novel ship. So we are doing it based on hazard study to reduce the risk to the level of LNG carriers. So Kawasaki Heavy Industries is developing a couple of designs, and they are comparing with similar LNG carriers. This is a 2,500 cubic meter LNG carrier and liquid hydrogen design. And here we are using the existing IGC code. Then interim recommendations at IMO, I will come to that later, because Japan and Australia jointly developed this and presented it to IMO, and IMO has adopted this recommendation as a basis for developing and building liquefied hydrogen carriers. And this is a comparison between methane and hydrogen. As you can see, the boiling temperature for methane is about 111 degrees Kelvin, whereas for hydrogen it's 20 degrees. That's in the normal temperature. Hydrogen is in gas form. And also the liquid density of hydrogen is 1/5 of that of methane. So these are some of the design issues that we face in developing this design. I'm sorry, this is the chart that I was telling. And at the bottom part, you can see a couple of demonstrations, comparisons between liquid hydrogen and liquid natural gas. And then one of the biggest problems with liquid hydrogen is when there is a leak, it is going to have a cryogenic havoc because the temperature is minus 253. So we have done a series of studies to find out what will happen if the liquid hydrogen is exposed to different media. Here the test shows it is exposed to concrete, and we have done a simulation on the left side. And we have created a CFD model to compare the experimental values to evaluate hydrogen leak and diffusion. And based on that, we have identified more than 89 issues with this new design that we have to face, out of which the hazard study shows that 10, as you can see the top in the red column, about 10 are very serious, and we are taking countermeasures to mitigate the risk. And based on the study, we have developed a cargo containment system. Kawasaki Heavy Industries developed it. And each tank is about 1,250 cubic meter, and we have 2 tanks for the 2,500 cubic meter LNG carrier. It's an IMO type C tank made of austenitic stainless steel. And so what we have done is we have given approval in principle to this tank, and our aim is to transport liquid hydrogen from Australia to Japan, as I mentioned before. And we are targeting the year 2020 because that's the year of Tokyo Olympics. By then, they want to have about 6,000 cars and about 100 buses to run on hydrogen fuel cells. So we are now working on the design, and construction will start soon, and the ship will be delivered in 2020, and it will transport liquid hydrogen from Australia to Japan. And this is the rule development procedure. The interim recommendations were approved by IMO at MSc 94 in 2014. Then we developed the draft interim recommendations, and a correspondence group was formed with many countries, Australia, China, France, Germany, and unfortunately India is not there, and a number of industry organizations like ICS, AIAX, OCIMF, SIGTO. And the draft interim recommendation was endorsed, and finally in 2016, IMO adopted the interim recommendation for carriage of liquefied hydrogen in bulk, and these recommendations we are using in the design. And then last year we have come to a bilateral agreement between Australia and Japan to produce hydrogen and transport hydrogen. And then last year we, for the first time of course in the world, guidelines for liquid hydrogen carriers were released based on the IMO recommendations and risk analysis and further study. And now coming to the conclusion, the pilot liquid hydrogen carrier will be designed, constructed and operated based on the IGC code requirements, the interim recommendations approved by IMO, and risk assessments. And hazard studies at feed stage have been carried out. We have done 2 such studies. And as and when the design progresses, we will do further risk assessments, including hazard, FME and all, so that we can accomplish a fully safe design. And now coming to the summary of the project, the Japanese government has so far spent about $11 billion on hydrogen research, because we believe hydrogen is the future, not LNG, because LNG is the transition stage. It cannot have a fully clean energy. So fully clean energy can be from hydrogen. So Japanese government already started about 10 years ago. So far we have spent about $11 billion. It's a lot of money. And as I mentioned, the aim is to import hydrogen from Australia to power the 2020 Tokyo Olympics. And about a minimum of 6,000 cars and 100 buses will be powered by hydrogen fuel cells. And it is produced from the solar side, it is produced in Queensland by where they have 300 days of sunshine. And also we are using the wind turbines in some parts of Australia, because when there is enough wind and it produces a lot of electricity which cannot be consumed into the general grid, it goes waste. And you cannot just stop the wind turbines just like that. You cannot switch them off. So we are diverting this excessive wind power into produce hydrogen through electrolysis, then store it somewhere, then try to transport it. And Japan and Australia have developed these LH2 carriage requirements, and is approved by IMO in 2016. And Klaas & Key has released the guidelines for LH2 carriers in 2017. And the first shipment is expected in 2020. And these are, on the right side is a couple of concept designs now we are working on. With this, I wish to conclude my presentation, and thank you very much. Thank you.
Thank you so much, Dr. Rahim. It was indeed quite informative, and it's a very brief and excellent presentation. Definitely there will be so many questions, which will, all the audience will have so many questions, and we'll raise the questions at the end of the session. The next presenter, he's a captain, and not only captain, he's a doctor as well. He has done PhD as well. We cannot see so many personalities in the maritime industry who are doctor as well as captain. He is such a person. And he is having more than 40 years of experience. Out of 40 years, for 5 years, he was the master of a vessel. Then remaining about 35 years, he was holding top management positions in maritime industry like shipping companies, consultancies, academic and research institutions. He was the founder vice chancellor of India's first maritime university, AMET, at Chennai. He is a fellow of Chartered Shipbrokers. He is a fellow of Nautical Institute of UK, and he is currently the chair of Nautical Institute of UK, Nautical Institute Chennai branch. And he is also a local advisory, he's a member of local advisory board of National Maritime Foundation Chennai branch. He is currently the resident director of Maritime Training and Research Foundation, that is promoted by Massa, Maritime Association of Ship Managers, Ship Owners and Ship Agents. I didn't specify the name, that is Dr. Captain Suresh Bhardwaj. Sir, welcome you on stage. And Mr. Suresh, Captain Dr. Suresh Bhardwaj is going to speak on the topic Global Diversity of Expectations, how can trade manage the contradictions? It's a great topic, sir. Welcome you, and we are eager to hear from you.
Thank you very much, Mr. Chairman. Just want to add to it that the training organization that I represent is promoted by Massa, which is an association of some big companies like Maersk and MSC, BW, Anglo-Eastern, Chevron, Stena. And this academy has recently in Goa won a prestigious award, which is fortunately been voted by the seafarers themselves. Gentlemen, ladies, in run-up to this particular conference, we had some excellent discussions with the organizers, Mr. Shaji and his team, thanks to Mr. Krishna Kumar here. And in these discussions, what came out was that the shipping sector is facing a lot of challenges from regulatory regime to meet some very ambitious and very zealous environmental objectives. There is a need to bring a voice of reason on what is achievable and how to go about it. The challenge is therefore to innovate. We have to create a convergence of environmental goals with commercial incentives. So there is definitely a global diversity of expectations. How does this industry manage so much of contradictions? Tricky question. and I was conveniently tasked to research on this and make this presentation. So, ladies and gentlemen, what are we talking about? What are the key words? Innovation, technology, regulatory regime, and green shipping. Let us first look at the connection, the nexus between these words before we go about managing them. Okay, looking at innovation and technology. Technology, ladies and gentlemen, stems from the acquisition of new knowledge. It is a result of a proper scientific inquiry. Technological change, as we all know, is the most prominent of all things that changes the rules of competition. And some of these competitive strategies, like when we differentiate with technology, market focus, competitor analysis, they definitely result in high performance. Let us see some Nordic example. You know, we talk about Norway, Sweden, Denmark. Mr. Jessen, he is a Norwegian himself. And this is what he says. In the face of aggressive competition from low-cost economies in Asia, he's talking about India and China. It is imperative for high-cost countries like Norway to build their competitiveness on innovation, knowledge-intensive products, to create a distinctive competitive advantage, which then becomes difficult to imitate. L'Orange, when he talks about strategic rethinking in shipping companies, he cites many examples of Nordic tonnage who embark on technological innovations, and they move from pioneering a concept to rapid expansions, and thereby they become world leaders. Gentlemen, there is a very specific funded research project called MARSICT, and this is funded by the Norwegian Shipowners Association. The objective is to improve the competitiveness of the Norwegian maritime sector by developing new technology. So innovation, ladies and gentlemen, at the end of the day is an economic objective. It is an effort to create something new, differentiation for economic gains. Yes. And the slow and selective diffusion of these innovations, that becomes a competitive advantage over strategically significant time span. The advantage which is obtained by early adopter is cumulative, because the early adopters add on much before the others can actually catch up with this. Next step, technology advancement, safety, and environment protection. Shipping, as we know, is a high asset value industry. When we have a failure causing a single marine accident, it causes the risk, a damage to a scale which is unlikely in any other transportation sector. Also, we know that the optimum ship today is not the one with the lowest cost. There is increasing concern with safety and protection of the environment, which has to be factored in beyond the lowest cost principle. Any firm creates value for the customer and returns for itself by offering a better perceived quality and a differentiated feature for which the customer is willing to pay. And, ladies and gentlemen, technology serves this agenda very well, with safety and environment protection thrown in. What are the main drivers for technology uptake in shipping? Unfortunately, it is the new regulations, which is aiding in advancement of safety and environment protection. And of course, it is the need to be competitive. But at the same time, there are expectations. There are expectations from the industry. The industry will have to be ever greener, ever safer, more efficient. It is the role of the innovative shipping company to satisfy them all. At the same time, they also have to remain economically viable. So what is the corollary? Whenever technology can be shown to give greater improved safety and environment protection at affordable cost, there will be inevitable pressure for its introduction. But as we know, in the industry, there are apprehensions. There are various questions being asked. Who should pay for these investments? Where is the investment? Where is the evidence of a payback for these innovations? The guys who are propagating this, they must do it on a no-pay basis. Or where is the proper impact assessment to justify a new regulation demand? The companies are reticent about the need for it, about the cost implication. Sometimes they're even apprehending safety being used as a ploy to get in more technology. The bane of this shipping industry, ladies and gentlemen, we are a globalized industry, the worst case of globalization. There are many stakeholders to a ship. Split incentives is a well-known factor in this industry. There is no way to govern this industry than through regulation. It's a regulatory-driven culture. It is clear that the technology uptake is largely because of a reactive stance of a regulatory compliance rather than being proactive initiative. Gentlemen, there is an established leading theory of regulatory politics that the concentrated industry groups do capture regulation. They bend it to serve their own interests. These suppliers, they put up a barrage of prominent eye-catching graphics extolling virtues of technology, and it really takes us a while to scratch beneath the surface to discover some slightly less enthusiastic take on this matter with self-serving objectives. In a global scenario like shipping, the fallout is that technology which is costly, it is the economically advanced countries who regulate first. They lead by selling technologies to the countries that follow. If you have seen the IMO proceedings, it is these countries who dominate these IMO proceedings. And more often than not, it is done behind the shield of environment and green shipping. Gentlemen, the dividing line, important to note, is that the dividing line between a social regulation which is covering health, safety, and environment, and an economic regulation of technology, it gets blurred when technology is passed off as enhancing safety. You know, Stiglitz, he is a very prominent critic of globalization. Globalization, big word, but Stiglitz has argued that the developed world has carefully crafted laws which give innovators the exclusive right to their innovations, and then the profits flow to them. Generally, if you see the pharmaceutical industries, the costs go beyond money value because the profiteering comes from companies when they research on lifestyle drugs rather than life-saving drugs. Why? Because the poor cannot afford to pay. There is something called Rnd Intensity, which is the ratio of R&D expenditures to GDP. This is in excess of 4% for OECD countries, USA leading at 41%. So, is this nexus clear, ladies and gentlemen, between the regulation of these words, innovation, technology, green shipping? Now we talk about managing. There is a need for us to move from regulation of technology to technology of regulation. It calls for exercising a caution in framing regulation. After all, we as a shipping industry, we just follow regulations. If there is no regulation, we will not follow, period. If that be the case, we have to be very imaginative in rule making. There is a need for responsible compliance which would assess all risks and its cost effectiveness before mandating requirements. There are different regulatory mechanisms. It is not just carrot and stick. You have performance standards, management system requirements, taxes and incentives, tradable allowances. In the environmental field, information disclosure, they can affect differently and they can also influence consequences. For example, if we just mandate that the scrubbers be put to contain the sulfur dioxide emission, no organization will ever go for lesser incentives to invent better methods. This is where we find a goal-based approach. The IMO is now adopting goal-based approach, a very good example, leaving the classification societies, the ship designers, the freedom to decide what they want to do with respect to technology, but meet a standard which is what IMO defines. Talking about technology of regulation, another major development is regulatory assessment impacts, to forecast the impact before enacting a regulation. And here, formal safety assessment encourages rules innovation in testing alternate designs of technology, selecting the best. IMO is seen to be adopting this of late, and this promises a balance between technical and operational issues, including human element, and between safety and cost. Actually, regulation of energy efficiency is a very good example of this. Another strategy which is normally used in environment protection is technology forcing, where the regulator prescribes a standard which the industry cannot meet, or at least not at the present acceptable cost. The intent is to elicit advances in technology and force the companies to invest in R&D. Here also we have seen IMO talking about EEDI, Design Index, Energy Efficiency Design Index, which is toughening every 5 years. It's a good example. Number 4, there can be social rules, practices, standards of accountability. They also have significant impact. We are talking about self-regulation, which is actually not new to shipping at all. For example, the insurance sector, they have created classification societies as a way to reduce uncertainty to manage the marine risks. Of course, there have been aberrations here, but it is now contained. It is superimposed by a system of self-governance by IACS itself. When they have come out with the common structural rules, we have just heard about it. And this practice is actually changing century-long practice of independent classification rulemaking. It is making a significant step by IMO, who has never been involved in the past. And they are now getting into detailed convention requirements for structures of ships. Another excellent example is Intertanko, self-governance, where membership is subject to a number of requirements, and members who are not found in compliance, they will be expelled from the association. So what can be some of the policy recommendations? A responsible, risk-assessed regime of regulatory requirements, including self-regulation, is the key. What is fundamentally lacking is policy entrepreneurship. which will encourage policy innovators to develop new approach to regulation for greater effectiveness, less caustic side effects, even less cost, and promote other desirable attributes. The regulatory design should be about consequences, what works, how much, at what costs, and what side effects. At the end of it all, ladies and gentlemen, what comes out really is this gap and a lack of synergy between research and practice. And this results in the practitioners who are there very much in the field, they become insufficiently aware of relevant research. At the same time, the research tends to be not sufficiently informed by the body of knowledge of practitioners which is there, excellent knowledge out there. The rules have to be performance-based, defined outcomes. They should set technological solutions in a prescriptive format. Not at all. It is the innovator who is making the design. He is best placed to ensure the safety of design, not the regulator. And also, care has to be taken to see that the additional requirement, additional regulations do not add administrative burden on the ship staff. One more new regulation, some more paperwork for the ship staff. No. And this calls for a user-centric approach. Many a times when the new technology is designed, the user is left out of it. In the shipping domain particularly, there is definitely a need to effectively leverage knowledge and insight which is gained in the rich practice which is there in the operations in the industry. This must improve across dialogue between research and practice. Research has to be encouraged. It is next to nil in the shipping sector, particularly. Shipping sector is driven by heuristics, by rules of thumb, trial and error. It is high time. Otherwise, we will be ending up just like another Philippines, a mediocre crew supply nation. That's all. Thank you.
Thank you, Dr. Bhardwaj, on highlighting the green ship technology related to regulatory regime, technology, and innovations. So we had two presentations. You have seen, we had a presentation from two speakers. The first presenter representing the classification society, and the second presenter, he's having a wide range of experience. He shared his management thoughts as well. He's a master mariner and he involved in a lot of experience in shipping, maritime segment. So the third person, he's from the equipment manufacturing side. He's from Warsila. He's an expert in propulsion. He's currently the technical director of Warsila Propeller Factory in Singapore. He was also heading the Warsila Propulsion Unit technical site in China and Singapore. He's having 23 years of experience and he started his career in LIPS propellers in China, and he's very expert in FPP, fixed pitch propellers, and CPPs, controllable pitch propellers. That's Mr. Gert-Jan van Goch. Mr. Gert, we welcome you on board. Gert has come from Singapore to attend this conference, and thank you so much, and the stage is set for you. Thank you.
Thank you so much. Good morning, ladies and gentlemen. I'm very proud and honored to be here today to speak to you about green shipping. I'm also very pleased that I see a lot of students in the room, because the students of today are responsible for the green shipping of the future. Within Warsila, we have many services and products that work on green shipping. Can be 4-stroke engines, 2-stroke engines, vessel designs, ship design, but also big data-based ANIRAM systems for voyage. Today, I would like to talk about improving propulsion systems on existing vessels, because the fastest way to improve green shipping is to revise, upgrade existing vessels. Within Warsila Services, we have several products to upgrade existing vessels. And we do a lot of investigations together with our customers to check existing vessels' performances and see what we can do to improve those. So we do not only deliver services and products to upgrade these systems, but what we do is to have investigation on each individual ship on CFD calculations. So let me go through some tactical sides how we take this approach. Warsila's approach towards improvement of propulsion efficiency. What we start with is an investigation on the existing vessel. Often this data is not available in 3D. So together with our client, we have a look at available information and build a 3D model based on previous old design data. From there, we make a CFD calculation of the existing vessel, resistance, wake field, and surface evaluation. Our experts then have a look at the results and select an energy-saving device, or even find areas for improvement in the hull, the propeller, the rudder, or appendages. If we have selected an energy-saving device, we start with the boundary element method to do a quick check on how to improve this efficiency-saving device for this particular case. When we finalized that quick study, then we go into the details with CFD and finalize our study and come with an optimum revision of the existing vessel. And as the last, we do a validation with full-scale sea trials. Let's go quickly through the steps of this investigation. And hereby I would like also to challenge the students who are into techniques to have a careful look at this for questions later on. First we start with the existing 2D line plans of the existing vessel, and from that we have made an automated system to create a 3D model. Sometimes we run into small difficulties with ownership of the data, but therefore we can sign NDAs so we can work together with our client to perform the study. If not all the data is available, we can use our databases and our experience to finalize the 3D hull of the existing vessel. When we have finalized the 3D hull, then we make a CFD calculation depending on the operation conditions of the existing vessel. And this we use as a reference. When we have the results of this investigation, then our experts discuss which would be the best way to improve this existing vessel. And that can be by either adding an energy-saving device, making some change, or even discussing operation conditions. In close cooperation with our client, we could select an energy-saving device. And in this slide, you see a few examples of that. We can have a post-swirl stator, which is called an Energo Profin, which is a propeller cap with fins that takes out the strong hub vortex that is normally present behind an FPP or a CPP propeller. In some cases, depending on operation conditions, we could even discuss applying a nozzle or removing a nozzle. We could discuss a new propeller design or change an existing propeller design, for instance, by a trailing edge modification. And our latest design is what we call an ergo flow, which is a pre-swirl stator that acts in front of the propeller and changes the wake field to improve propeller efficiency. Also a possibility is to do some changes on the rudder, which we call an Lng Pack, where we combine rudder and propeller operation. Here I would like to show you an example case that we recently did for a client, where we have investigated the use of an Lng flow, which is a pre-swirl stator acting in front of the propeller. This pre-swirl stator acts by changing the vertical direction of the flow into the propeller on one side of the propeller disc. In these diagrams of the wake field, you see on the left side a traditional wake field, where the colors represent the axial flow and the arrows represent the radial and tangential flow. And the working principle of this Lng flow is that where the propeller blade goes down and the water comes up, we have a good efficiency. But on the other side of the propeller, where the propeller blade comes up and the water also comes up, the efficiency is way less. So at that side of the propeller, we design this pre-swirl stator. And what we try to achieve is what you see in the middle picture, that all the arrows rotate against the propeller, which is something that we would never achieve, but we try to disturb as much as possible to come close to that ultimum wake field. At the right side, you see a wake that would be created with this pre-swirl stator. In this particular case, where we did a study for a client recently, we found something completely different. And the importance of this is that we case by case investigate how a vessel is performing and what we can do to improve. And in this particular case, in this wake field, you see two very strong vortexes that our client was not aware of. This vessel has been designed 18, 19 years ago with traditional way of designing, and with today's tools, we find that that design is not perfect against today's standards. So we had a careful look at the results of this one, and we investigated how to continue with this pre-swirl stator. The way we investigated pre-swirl stator is not that we have a standard design, put it in front of the propeller, and the customer achieves some small figures of fuel improvement. No, we use boundary element method to make a design of this pre-swirl stator, and then with today's computer power, we make iterative steps, thousands of them, to optimize this pre-swirl stator. So we take a look at the number of fins, the pitch of the fins, the camber of the fins, the location of the fins. So this is an iterative process where we really optimize this device for this particular vessel. This is something that could not be done years back, simply because of the computer power needed for this approach. In this slide, you see on the left side the wake field that was existing, and on the right side you see what we finally achieved with this boundary element method. Let's say the rough method that we used to find this. This optimum that we reached is then later put into CFD, and with CFD we do the fine-tuning. So we first take this rough approach with boundary element method to come to a rough design that we finally tune with CFD. CFD takes, even today, too much time and computer power to do a lot of iterations. So here on this slide you see the differences on the left side between boundary element method and on the right side between CFD. So with the boundary element method, several things are excluded. So it's an inviscid flow, it's irrotational and incompressible fluids calculations. Where with CFD, we just used Reynolds average Navier-Stokes analysis, and everything is taken into account. In this picture, you see a CFD full-scale result of our final design for this particular case, and this is validated against joint industry topics and validated with full seals trial and model test that we have from the past. Here you see some pictures that we achieved with meshing of the hull, the existing hull, that was input for these calculations. Here you see the final approach of the pre-swirl stator in front of the existing propeller. The existing propeller is always taken into account as well, because when you add a pre-swirl stator, the propeller will become heavy running, so there will always be done a trailing edge modification. That trailing edge modification is taken into account in our final calculations. Also, in our approach here, we even take free surface into account. So when we have finalized the 3D hull, we do free surface calculations in CFD to take that also into account in the wake field and the self-propulsion tests. And in this slide, I would like to see you the vortice, where you see this energoflow pre-swirl stator in front of the propeller, and you see all the tip vortices that is generated and how they are moved over the propeller and the rudder. So all these things are taken into account to avoid that there will be any damages, cavitation caused by these upgrades. Here even we take a look at the flow, how the flow follows the surfaces of the pre-swirl stator and the propeller. So here you see all the flows are following the surfaces very smooth. And as a final check, we have a look at the 3D streamlines over the existing hull, pre-swirl stator, and the modified propeller. And here I would like to conclude that our new approach towards upgrading of existing vessels by taking into account computer-aided engineering can bring high fuel savings. And depending, of course, on the vessel type, vessel size, we can expect fuel savings over 10%. So we are very pleased that we can work on this together with our clients for lifetime upgrades of existing vessels to make sure that green shipping is starting already today and not in the future. Thank you.
Thank you so much. Thank you. Thank you. Thank you, Mr. Gert, for highlighting the propeller efficiency using latest state-of-art computer-aided design. Next presentation, that's from the students. That's 3 intelligent students from the Department of Ship Technology. As I said, we have to hear from experts. We also have to hear from students as well. Students always used to come up with some fresh thoughts. I have a story to tell that actually. One of my closely associated friend, he got married to an East European and he's from Kochi. And they have a son as well. So they could not come to Kerala for quite some time. The son is now almost 8-9 years old, but around 6-7 years old, because all of them know the coconut, because Keralites, we are all used to coconut trees and coconut oil. So he hasn't seen a coconut tree. So his father asked him to draw the coconut tree. What he has drawn was a branch, the full tree with branch, and in that you can see the coconuts like that. But the tree with branch and coconut, if Keralites, we look at that, we will laugh. But that's that's an innovation. That's his perception. That's how he views things. He hasn't seen it, but he is actually precipitating the idea. He's expressing his idea. So the students, I spoke to the students actually. They are quite confident. They have done a lot of research, and I'm so happy to invite them on board and to speak on the topic LNG dual fuel propulsion systems. Cadet Suman Dutta, Cadet Lavi, Gulia, Cadet Abhinav, Aravind. Welcome on stage.
The present world is striving for a better, greener fuel for the future development. and the energy demands are always been rising. In the coming years, it will even rise more because of the population growth and the economic development. Good afternoon, everyone. We, the students of Department of Ship Technology, CUSAT, are here to give a presentation on LNG dual fuel propulsion, which will be the propulsion for the future. We'll be going through the regulations, environmental factors, and affecting the introduction of LNG as a dual fuel, and compare the LNG dual fuel engines with the existing engines also. The new LNG pack concept, which was first introduced by the warsila, will be discussed. And finally, we'll conclude by elaborating the economic and the fundamental factors that affect LNG as a dual fuel. Now, as I've said, energy demands are rising day by day. Energy demands are going to rise even higher because of the economic development and the population growth. So, studies have shown that the renewable energy investment could create more job opportunities in the future than coal or oil. We can see the environmental factors here, the NOx, SOx, and the particulate matters. They have already created local impacts. The NOx, SOx, and particulate matters, which has already created the local impacts all over the world. But the CO2, it has created an impact called global warming, which has risen the global temperature by around 2 degrees Celsius globally. We have to look into these environmental factors before coming up to LNG or any renewable energy for that matter. Until now, we were having maritime trading routes as follows, which were free and having no stringent rules at all. But from now, we are having emission control areas, which are going to come up. Emission control areas which are going to come up in the American coast, the Atlantic coast, Baltic Sea, and North Atlantic Sea. And the IMO has designated ECA under the Regulation 13 of MARPOL Annex 6 to control NOx emissions particularly. We till now were having machinery options of MGO, the marine gas oil, which includes selective catalytic reduction method also, and HFO, which is the heavy fuel oil, and with a scrubber and SCR technology as well. But LNG is coming up in the future, which can create a new spectrum of energy resources as a part of renewable energy. The introduction of EEDI and EEOI, the Energy Efficiency Design Index and the Energy Efficiency Operational Index, has demanded the shipping companies to bring out with alternate fuel sources and greener and cleaner fuels in the future. In total, we can say that the LNG can reduce the emission of CO2 by about 25 to 30%, and NOx about a whopping 85%. And in future, we are expecting it to reduce by even 90% with the inclusion of new technologies and lean burn concept. And there is absolutely no SOx emission with the LNG fuel concept. There is no particulate matter emission, no visible smoke, and no sludge deposits at all. Now, this was about LNG as a fuel, but it is more relevant to consider it as a dual fuel concept in the future, which could revolutionize how we see renewable energy. So I would request my colleagues to take over to discuss the technical matters about LNG dual fuel.
So let me first bring you to the consensus why we want the dual fuel engine and giving a stress upon why LNG should be complied with it. The two famous personalities on the screen. First one, Nicholas August Otto, the person behind the most of the discoveries of gases and its phenomena, and the other person, Rudolf Christel Carl Diesel, the person behind today's popular engine, the diesel engines. They did a lot of research. So, with the researches, a graph was plotted between the crank angle and the cylinder temperature, and it was found that there was a sudden great temperature difference for the cylinder curve as compared to the Otto curve. From there, it was inferred that the bigger temperature difference, the more production of NOx. And as we know, NOx is a major component of greenhouse gas phenomena.
At present, we have three options in terms of the technology for the propulsion systems of our ships. These are namely the dual fuel technology, the spark ignition gas, and the gas diesel.
Coming to the chronological order of this technology, the first one came in the year 1987, the gas diesel technology. The second one came in the year 1992, that is spark ignition technology. And the latest one, which we are dealing today, is the dual fuel technology, which came in the year 1995.
Of these, the dual fuel technology is our choice. The main reason why the dual fuel technology has the advantage over the other alternatives is that it is in compliance with the latest Tier 3 regulations of the IMO. It uses LNG, which is a low pressure gas. Moreover, it has fuel flexibility. That is, it can be used with the heavy fuel oil, the marine diesel oil, the MGO, and other fuels.
As spoken about the why it is our best choice, speaking about its characteristic, it has got a very high efficiency, and moreover, its workability at low gas pressure. And also it has the fuel flexibility that it can work either in the gas mode or as in the diesel mode. The final one and the most demanding feature of any of the engines that required today and the need of the hour is the low emissions, as the rules are getting stricter about the greenhouse gases. So it gives a least amount of NOx and a no amount of SOx and a very reduced amount of CO2.
Among the other advantages of the dual fuel technology, we have redundancy, which means that there is a backup without any interruption in terms of the power or in terms of the velocity. The vessel rerouting is possible. Gas supply is not a limitation. There is no phenomenon like take me home. Even if one of the fuel supply system fails, we always have an alternative option ready to continue the smooth operations of the ship.
Coming to the application where it is presently is, it is mainly right now in 4 segments. The first one mainly concentrated on the power plants, the second one the merchant vessels, the third one the offshore vessels, and the fourth one mainly is cruise and ferries. And with the present trend of shifting the energy towards LNG side, we might very soon see Navy also getting this LNG onboard ships.
Now let's come to the properties of LNG. LNG, which in composition is predominantly the methane. Methane, which is an odorless gas, which is non-toxic and it is non-corrosive. Further, the LNG is a low-pressure gas, which adds to the safety point of view. The boiling point of LNG is minus 162 degrees Celsius. The purified natural gas, when it undergoes the process of cryogenic chilling, the temperature of the gas is reduced below the boiling point, which further leads to the liquefaction of the gas. And it gives us what we know as the LNG. So during this process, the volume of the gas is reduced by 600 times the initial volume, which is a major advantage for us in terms of the efficiency of the transportation.
Coming to the present situation, as most of the owners are worried that their vessel might get a red card soon with more stricter rules. So now what warsila has brought is that the concept of LNG pack, through which we can convert our existing vessel into an LNG compliant vessel and which can meet the present rules and regulations.
The LNG pack system contains various components, starting from the bunkering station, which is also the fueling station. The fuel is transferred to the tank room, from where it is channelized to the main engine room through the LNG gas evaporator, where the gasification of the LNG fuel takes place. The crucial component of this system is the gas valve unit.
As mentioned, the crucial unit, the gas valve unit, its main features are that it can be located at any place. It does not need a dedicated compartment for it. Mostly it is preferred to be kept in the same room, that is the same engine room. And also its plug and play concept is also an important feature of it. Coming to its integrated ventilation system, which also gives a overpower about this technology.
Now coming to the terms of the LNG storage, the amount of gas LNG that can be stored in a defined space is much more than the amount of the diesel or the other fuels that can be stored in the same space, which is a great advantage for us.
Coming to the location of the LNG tanks, it is preferred to place it outside. We might have other option, but it is preferred as it will not take the space which might be used for other purposes inside, like for accommodation and other purposes. And also, these tanks will get a better ventilation outside.
Now coming to the storage, we also have that we use the specially designed steel cryogenic vessels and the tanks for the storage of LNG.
speaking about the LNG distribution system, as most of us will be having the common question, how will this LNG be transferred to the vessels? So this can be either done directly or indirectly. Speaking directly, the LNG terminal, that is a bunkering system, can directly feed a LNG compliant vessel, or indirectly it can feed a LNG feeder, that is a vessel specially designed to carry LNG, and it can feed a LNG compliant vessel in the middle of the sea.
The map shows the existing and the proposed bunkering stations all over the world as per the data of September 2013. It is clearly evident from the map that there is a high concentration on the Japanese coast, the European and the American coast, while there is a huge scope of development in the South Asian region. This is a typical LNG feeder vessel.
As I mentioned, the LNG distribution cycle, but whatever the case, the LNG storage tank is one of the main component of it. It has got particular cryogenic properties so that LNG can be transferred easily.
Now coming to the energy consumption and the fuel cost. If we set the energy consumption and fuel cost of marine gas oil at 100% for the purpose of comparison, it is clearly evident that the LNG takes only 66%. That is the 2/3 of what the fuel cost is of MGO. While the energy consumption ratios are more or less the same. The advantage of fuel cost is a big advantage because the fuel is the main part of the annual expenditure of the ship.
Speaking about the machinery investment cost, the only being that this LNG technology has got is its initial investment price. As we can infer from the graph, the MGO has got the least installation cost, and whereas compared to the combination of HFO plus scrubber, it is almost equivalent to LNG.
Once we have made an investment into the LNG systems, there are costs like the maintenance cost, the fuel cost, the lubrication cost, which we incur annually. So when all these costs we compare as an annual expenditure, the LNG comes out to be the least expensive fuel.
Coming to the payback time, as it is one of the most important calculation that an owner would certainly do, as it decides after how much time will an owner get a profit. So if we infer from the graph, the LNG takes around 1.6 years when compared to MGO, and whereas the combination of HFO plus scrubber takes more than 3 years for that payback time.
As already brought up by us, that the LNG system, the dual fuel system, is the major advantage is of the exhaust emissions. The SOx emissions are almost nil in case of LNG systems, and the NOx emissions are also reduced to a minimum levels. Now coming to the safety. As already brought up, the LNG is an odorless gas. So odorant is added in this to detect any kind of leakage at the earliest possible. The next advantage in terms of safety using the LNG is its auto ignition temperature, which is 595 degrees Celsius, which is way higher than the operational temperatures. That means it is a safe fuel. What if the LNG spills out? In case if there is a spillage of LNG, it is the natural property of LNG to evaporize and to disperse quickly. Now the question arises that how much expenditure we put inside for maintaining such low temperatures for the storage of LNG, because we maintain it below minus 162 degrees Celsius. So the answer to this question is given by a fascinating phenomenon, that is the auto-refrigeration. In case of auto-refrigeration, what happens that the vapor boils off, and the heat for this boil off, for the phase change from the liquid to the gaseous stage leads to a cooling effect on the remaining part of the liquid. Because the heat is derived from the remaining liquid, thus the remaining liquid is maintained at the desired temperatures. Further, the storage tanks have a good efficiency, because of which this phenomenon is very efficient enough for maintaining the desired temperature, as the boil off gas is very limited in terms of its volume. And this boil off gas is not a waste. We can use this boil off gas for other fuel source. And in case if we store it, then we can further process it and revert it back to the form of LNG.
Coming to the EEDI, as I previously mentioned, the Energy Efficiency Design Index. It is also one of the important concepts that an owner will certainly look. That is, it decides how much efficient your engine is. And if your EEDI is less, then it means that your engine is better than the other one. As you can infer from the graph, the LNG has got the least EEDI as compared to the other options.
Now we admit that with because of the technical difficulties, our industry has a low probability of engulfing this technology in soon. But considering the statistics, most importantly the economic and the environmental factors, we should say that LNG has a great potential on its own. It can be the fuel for the future because it has got lower emissions, it has got short payback time, better efficiency over other conventional fuels that we use today, and has got compliance with the present society rules, which is very important as of now. Because in future we can expect more stringent rules getting stricter of the shipping companies and classification societies, putting it to a matter of a discussion. Thank you so much.
Thank you so much. Once again, thank you. Abhinav is from the 5th semester and the other two guys are from the 7th semester. He's the youngest among the three. Thank you so much. Great presentation. Thank you. Now we are coming to the last presentation related to green ship technology. That's getting presented by my teacher who taught me basic naval architecture as well. He was a faculty member of CUSAT, Kochi University of Science and Technology. He also worked as faculty in at Strathclyde University in Glasgow, and is currently professor at the Department of Ocean Engineering, IIT Madras. That is Dr. Professor P. Krishnankuti. He is a fellow of Royal Institute of Naval Architects. He is the chairman of RINA Chennai branch. He is a member of SNAME, member of ASME. He is a chartered engineer, and he has published more than 100 papers. I like to call him as a scientist because the paper which is going to present today, it's actually part of the research which is currently doing and which is doing the research in that particular subject. So that's, the topic is energy efficient and eco-friendly flapping foil propulsion system for marine workers. I welcome Dr. P. Krishnankuti on stage.
Yeah, I think it's time for lunch. Maybe I don't take much time for that presentation. Okay, I belong to the second batch of ship technology department. So immediately after that, I joined as a faculty member here in the ship technology department, worked for about 25 years. And I left the ship technology department in 2006 and with now IIT Madras for the last 12 years. So what I'm going to present here is part of my research work, or my students' research work actually. So this is looking to the energy efficient and eco-friendly flapping foil system, which can apply to marine vehicles, maybe submerged vehicles and also surface vehicles. And this is something which is close to the nature, which is being adopted from fishes which move with flapping their face. So if you look to the locomotion, so there are different types of locomotions based on land, fossorial locomotion and terrestrial locomotion, that underground, above ground, then water, and also the aerial locomotions. I'm not going to detail, these are different types which people are trying to mimic for applications, engineering applications. I just concentrate on the aquatic aspect. Different species use different methods for propulsion. through water. Some uses lift-based, that is using the pressure difference under the fins to get a lift and also the forward motion. And some use a drag type, just pushing water. Then some use the angulation motion, that is just fluttering the body and the fin to get a propulsive force and move forward. And the other one uses just take in water and compress it and push it out, which is a jet type propulsion system. So this is a turtle which comes under the lift-based propulsion system, which is based on the pressure difference used coming on the. So this is a lift-based flapping foil system, which uses a pressure difference of the fin when it's fluttering, when it oscillates, and it is used to direct the fin in such a way that it can move forward. And this is another undulation mode. You can see that the eels and also fishes, which undulate the fin and its body. Okay, okay, this is the one which the eel which changes, gets its motion forward by the body undulation, and also the fish which undulates the fins and the body to get the oscillation, get the force. So here, another one is a jellyfish, and which is based on the jet propulsion. It takes in water and compresses is using the muscles and push it out, getting a thrust, making it move forward. And this is a skid which also does the same thing, take in water and compress it out. So these are different types of aquatic motions used by aquatic living beings for its propulsion. Also the scallop also takes water and also almost the same as the jet propulsion. So advantages of biomimetic propulsion, this fin-like propulsion system is, it can be used, the same fin is used for propulsion and also for maneuvering, that is changing the direction and also for the positioning. And these fin propellers will not create a cavitation and doesn't create a wake, which cannot be as in the case of screw propellers, which creates a lot of disturbances and also creates cavitation. These things are not present in the natural propulsion system. And also it has been found that efficiency is more, which obviously is leading to less fuel consumption if the system is implemented in the marine vehicles. And also for the same energy, it gives a longer endurance. And one more aspect of this is it creates less noise, that is having more stealth nature. And it doesn't create much disturbances to the flora and fauna of the marine environment, making it more eco-friendly. And if you look to the advantage of this propulsion system, if you look, normal vessels is take a longer distance for getting a turning, and the hull propeller induces a lot of vibration if it's a screw propeller, and it's not as stealth in nature. Whereas when it comes to the aquatic propulsors, you see the efficiency is more. It is reported up to 80% compared to the screw propellers of 60%. And the maneuvering ability, it is almost turn it by its own position. And it's having a very good stopping ability. if you, it has extensive applications, this biomimetic propulsion systems. Marine applications, renewable energy, that is the same flaps can be used for generating energy from waves and currents. And it also has biomedical applications, nanotype biomimetic robots are used for, drug delivery systems. It's also used for in aerospace application like birds and autonomous aerial vehicles. And also it is being planned by NASA to use in Jupiter's moon for the space application. It has extensive naval applications, mainly from the stealth characteristics of it, and there are autonomous underbodies which are being planned with a fin propulsion system. So if you look to the development of the biomimetic propulsion system, then you have to know the basics of it. And then if you look to the basics you get from the nature, and then replicate it to get the numerical and in the numerical environment to understand the physics of it. And the numerical evaluations are finally checked with the experiments, and then you take it to the field applications. So this is this is one of the robo fishes being developed by MIT. So we can see that the fins are being used. That is called the caudal fin, which is the tail fin, which is being used for the propulsion. And the side fins, which are called the pectoral fins, are used for controlling its direction. It also contributes to the propulsion. And the fin at the top, called dorsal fin, which is used to keep its stability in the horizontal plane. I think the battery is gone, it's not moving. Okay, I just want to show some of the studies what we did at IIT Madras. So we just took a shark fish, a small one. I think it's about less than a feet long. They put it in a tank, there's a glass tank, and using PAV systems, we tried to find out the contribution of different fins on the propulsion by looking into the particle level behavior. You can see that the fins which shows the vortices. See, basically the fin oscillation is the one which creates vortices and particular frequency of oscillation and amplitude of oscillation. And at particular speed, it creates a set of vortices called reverse von Neumann vortex, which results in producing a jet, making it propel forward. So this we have applied to that of a ship model using two fins at the bottom of the model, ship model, and just flapping the foil, the model is moving forward, so it generates a thrust by the flapping, and usually this doesn't create much disturbance while it's producing the thrust. So these are some of the results which have been obtained from the measurements of the test, which has been already reported in journals. So the same thing has been done in the numerical environment using CFD analysis. This is a two-dimensional analysis. So you can see here that the first figure which shows it's a vortex which is called von Neumann vortex, which generates a drag, and under certain conditions, under certain Stokholm number, it produces the vortices in the opposite directions, which generates a thrust. So if you oscillate the fin in such a condition, then it produces a thrust. So this has been extensively studied in CFD environment for rigid and flexible flaps. As we have seen the fishes, In nature, the fins are more flexible, and due to the flexibility, the efficiency goes up. So we just want to identify that, and okay. So these are the different, CFD modeling part of it. Some of the equations and force measurement, and finally the thrust against the straw hull number, which is the first figure plotted there, and the second figure is the one which shows the efficiency. So we have seen that the efficiency is giving up to 70%. You can see that it's up to 0.7. Then we have undertaken another study, just mimicking the flapping the fin of a tuna fish, mainly the tail fin. And that has been applied to, okay, this is the mechanism with which the model has been made. So this has been applied to a model with the tail fin just mimicking the tuna fish. You can see the model is just moving forward with the flapping fin, and the measurements done on thrust and velocity attained at different frequency are shown here. And that has been taken to the application of underwater bodies, the fins. And these are the mechanisms, and this has been tried. We are just still in the development stage for the underwater bodies. It has been done at the surface condition, and the facing challenges with the water leak problem, seals for that, because this has to be taken underwater. So leaking is a major problem there. So now it is being extended to application to surface ship models, and CFD studies, my PhD scholar is here who is doing this. So we have done it in calm water condition and wave condition in CFD environment. And here also we found that the efficiency is going beyond 70% for the propulsion system. And the model, we are developing the system for this, which will be applied to a model surface model to study the details of it, what would be its effect when the fin is subject to different oscillation parameters, and what would be the thrust developed, what would be the speed, and what would be the efficiency. So generally, we found that based on the previous studies, the efficiency is coming 70% and above, and it also has been reported in the literature, it comes high. So this application, if it extended to commercial level, naturally there will be a reduction in the fuel consumption, reduction of emission, and becoming more eco-friendly. And another aspect is, unlike the screw propellers, this is not going to create a lot of disturbances in the water, and that means the flora and fauna of the marine environment will not be disturbed much, and it doesn't cavitate. It is not going to give generate a signature that's a wake and all that, which can be easily identified by an enemy vessel. And when it applied to underwater bodies, it can have a naval and coastal application for underwater surveillance, and it can do the operations silently. It can even intrude into the domain of enemies, even to get the data of the enemy vessel signatures, which will be useful at later stage during the time of war. So there are different advantages, unlike generally if you consider improving efficiency of engine, improving and reducing all other techniques, still confining to only the screw propulsion, whereas this type of propulsion has an advantage over the other one because of the higher efficiency and more stealth in nature, creates less disturbance. So that's what, to summarize it, we have gone through the basics at the theoretical level, numerical level, and also to the experimental level, and getting into the application level now. So this has been done at the particle level, studies which you have seen PAV, and there are some of the conclusions based on the studies and the graphs which I have shown. So though, due to lack of time, not going to the details of that. With that, I conclude. Thank you for the opportunity.
Thank you, sir. Thank you so much. I think I appreciate if you could stay back actually, because we'll have a question and answer session. So I invite all the paper presenters to come on stage. Dr. Rahim, Captain Dr. Suresh, Mr. Gert, and Abhinav. Abhinav, please come. It's time for questions. So now the panel is here. I mean, it's time for the audience and delegates actually. But what I request is raise your hand, identify yourself, and please raise any of the questions.
I'm Ajay Das, Executive Director from Masconduct Shipbuilders Limited. I just heard this first particular paper from Dr. Abdul Rahim. He just spoke about the bubble-related technology which reduces skin friction. I just wanted to know whether this particular technology has been used in vessels which negotiate, frozen sea, for example, icebreakers or polar research ships. Has this technology been used in those kind of ships? If yes, what are the merits? And of course, the merits are known. Does it bring any complications in the equipment? Thank you.
Thank you for the question. It's an interesting question. The bubble technology is most efficient in shallow draft, wide-bodied ships, so that the bubble will remain there. Currently, a couple of module carriers, and then 60,000 deadweight chip carriers, wood chip carriers, and then a couple of passenger ships, and 85,000 that's Kamsarmax class ships. They all use this technology. It is not applied to polar and other ships yet. Thank you.
Thank you.
Simon from second batch. Question to Rahim on the first paper, and also to warsila if it's applicable to you. The question is, you have mentioned about hydrogen fuel cell for propulsion. In fact, that's fine, good. How much is applied, I'm not going into the detail. But what about other fuel cells and how it is going to be applied to marine sector? That's the question.
Okay, thank you. But currently we are concentrating only the hydrogen-powered fuel cells, because hydrogen is one of the most abundant available fuel in nature. Only thing is that you just do electrolysis of water, you get hydrogen. You burn it, you get water. So it is. We are not currently working on any other fuel cells.
My question is to
Captain. Please identify.
Yeah, I'm Krishna Kumar, first batch. My question is to Captain Suresh Bhardwaj. It's a very provocative presentation you made in a general context. And you finally, as I understood, you are advocating the goal-based approach and the performance and the formal safety assessments and those kind of frameworks which the international shipping is following. Now in India, there's a lot of focus on coastal shipping and inland waterways. But there is no such, it's still based on rules and prescriptive approaches what we have. Why not a goal-based approach, formal safety assessments and those kind of modern ways of thinking rather than prescriptive approach? What are your thoughts on that?
Yes, thank you. That was exactly the idea to say that if we are an industry which is being driven by regulation, there are different ways of making regulations. And these goal-based standards and formal safety assessments are the new approaches which is being organized, which is being adopted by IMO to make the regulatory approach more proactive and most certainly these are the examples which need to be followed in countries like India to develop in this area. And I'm very happy that Madam DG was sitting around here and she's taken it up, and hopefully we should see some developments in these areas. Sure.
Thank you.
Thank you. I'm Professor Ananta Subramaniam. Of course, first time in the first batch of Kochi University, Naval Architecture. Now, first thing, compliment to all the 5 totally diverse aspects of naval architecture, shipbuilding and research, all beautifully presented. My compliments to all of you. I cannot ask all questions to all of you, but I'll just stick to 2 questions I would like to choose and say. Dr. Abdul Rahim, you mentioned of fuel emulsion, injecting water vapor into an engine, which will therefore bring down the temperature. But is it not contrary to efficiency? That is my first question. And to Dr. Bhardwaj, it was a beautiful presentation of a very complex thought process which nobody really thinks when we are in the developing world. We just follow what is being told, but you brought beautifully. Too difficult to ask too many questions. I just want to say one thing, the remark you made, regulation of technology changing to technology of regulation. I think that is a beautiful way of, at least for India, to look forward and to bring about changes. Of course, any additional comment on that after Dr. Abdul Rahim answers. Thank you.
Thank you. Extremely good question. When we are mixing water and fuel, of course the efficiency goes down. But if you look at the total amount of fuel used, so it is, if I remember correctly, in one of the projects, it is 16% less fuel that we need to use to get the same output. So though it seems that the water and fuel mixture cannot be just a substitute for fuel, because it depends on the total heat it produces or the output it produces. So the saving is about 16%, not 50-50. Thank you.
Thank you. Yeah.
Thank you very much for these compliments, and this is exactly what we wanted to drill out in this country, that we seem to have a lot of strict regulations, but in the veil of these strict regulations, which appear to be very strict, we still have probably the worst of tonnage which is going around our coast. We have the education system and maritime which is dwindling down, and as I mentioned, that if we continue this approach, this country will be no more than a mediocre crew supplying nation like Philippines. It is very important that we get a different approach towards governance, and I can see the change which is now coming down from the center where we had Mr. Modi, who was actually in Gujarat, and he has seen the shipping develop himself. And his approach to governance is totally different. Why do you want me to certify a lift in your building? If you want inspectors, that is my responsibility. I will give you inspectors. But certifying a building, I should certify. You are the building constructor. You certify. I mean, there is a total difference in approach to governance, and this is something which needs to be brought into the system of governance in our country. And getting into a position of governance with a master's license or a chief engineer's license is good enough for driving a ship. But when we are there in the chair, what is rule making? What is the basic idea of rule making? How do we direct a society to do a particular job? This is what we need to really invest in and make the regulatory framework much more proactive and much more user friendly. Thank you.
Thank you. Any more questions? Yeah.
I am Commander Sakariya from the 4th batch. My question is to Dr. Krishnankuti regarding the flapping foil propulsor. You said it has an efficiency of around 70%. Is it the efficiency equivalent to an open water efficiency for a traditional propeller, or the overall efficiency? That's the first part of my question. Second is, do you think in future, suppose you develop this mechanism, you can apply it for higher speed vessels?
Okay, coming to the first part, we have done the open water condition, as you said, the fin alone has been considered, and we found that it was coming up to 80% efficient. And we have done the studies, if you remember that video, the fin was much behind the vehicle, so the interference of the vehicle on the fin was insignificant. So that is also equal to the open water condition. Maybe in reality, the last video which I've shown, which is for the surface model, we will be measuring to that because the fin is going to be very close to the body. So what we have studied so far, we have done the open water condition and behind condition, but in the behind condition, the fin was away from the hull. So that means the hull interference was insignificant. So you can take it as also open water. The efficiency has been measured as 70% plus. And coming to the second part, whether it can be applied to high-speed vessels, of course, this is only the beginning part of it. There are many groups around the world working on the similar projects, including MIT and other institutions. So it's still in the development stage. So we'll start initially with the low-speed vehicles. And this is also, as I said, one of the major advantage of this is the stealth characteristics of it. Doesn't create much disturbance, which obviously have a very strong naval application. So that is what is the initial application looking for. Of course, if you look to the whales and all that, which migrates from ocean to ocean with a higher speed and endurance, you can say, well, there is a scope for looking into higher speed vehicle application at a later stage. Thank you.
Thank you, sir. Students, why the students are silent actually? Because students normally should have so many questions, right? No question from the students? You're not a student?
No, I'm not a student.
Oh, then please.
I'm asking questions.
Sorry?
I'm asking a question to the students.
Okay, that's very good.
That's
Very good
about
comment actually.
LNG conversion. Okay, you mentioned a lot of things about having the LNG tanks and then the gas evaporator and all those things. But what is the basic modification changes that you're going to do in a basic diesel engine or marine heavy engine? How is it compatible? Is it really practical on existing engines? It can also be take advice from warsila on this aspect.
Yes, sir, of course. As I have already presented in the presentation that it is a courtesy of warsila that they brought the LNG pack concept. So through that, we can convert an already existing vessel. That is, if a vessel is running on diesel, it has got emission problem, like more amount of NOx and SOx production. So which is like rules and regulations are becoming stricter. So of course, our owner will be worried that his vessel does not get a red card soon. So this concept is brought by warsila to get a LNG pack onboard a system. So with this, already existing vessel is converted to a LNG compliant vessel. We use a simple, as we have made it simple in our presentation, that the fuel comes from the bunkers, either the terminal or a LNG feeder, then it goes to the tank. And from the tank, using the evaporator that is supplied to a GVU, that is gas valve unit. And through this gas valve unit, it is supplied to the main engine. Now this gas valve unit acts as a valve, like it is a switch. Whenever you want it, it uses the plug and play concept. Whenever you want to the LNG to the main engine, you just use that gas valve unit. And it is a very simple concept as explained on the slide.
Thank you. Maybe Gert, you may have some thoughts on that because in fact, students are promoting your product. That's something you have to identify that.
Well, I think the answer was very complete. I have nothing to add to this. Thank you.
Okay, thank you so much. Thank you. Any more questions from the students actually, because we don't have much time because we have to break for lunch. Please, yeah.
Yeah, this is Thomas Jolly. I'm the 5th batch. I used to work for Bhumi Armada. I have a question to all of the panelists, and pardon me if I missed something because I had to step out, so I may have missed something in the presentation which is related to the question I'm going to ask you. Now we talked about operational efficiency, reduction of capital costs and so on, and reduction of operational costs. So what about the total life cycle costs and the effect on the environment to make it green? Like for example, we have these, is there any game-changing design methods that we're using to ensure that through the life cycle and towards the end of the ship's life, for example, when we break it down during the operations, we address, but during the breaking down of the ship and so on, is there any design concept that is being done to reduce the negative impact on the environment and also to the people who do that? I think maybe Dr. Captain Bhardwaj might be able to address that.
What you're referring to is as the life cycle costs with respect to a product.
No, the life cycle cost to the environment.
To the environment.
To the environment, through the entire cycle of the ship. That is not just during the operation, which a lot of people talked about, right? I mean, we have a lot of ways in which we can increase efficiency, reduce operational costs, and so on.
Yes.
But there's untold cost to the environment during the shipbreaking process, for example.
Yes. Very complicated.
And the cost of dismantling the.
When we talk of life cycle analysis, I think if we can really bring about life cycle thinking, that would be a much greater. When we talk of life cycle analysis with respect to products, we are really talking about values. What is the environmental burden at each stage, right up to the scrapping, maybe recycling as well, which is a big game. It is not, even in the simple manufacturing industry, life cycle analysis with costs attached to it, very few. I don't know really what should be the thinking, as long as we are bringing this concept in thinking itself, and we are talking about, let's say, non-use of asbestos in the recycling of ships, that should be good enough at this point of time. But ultimately, yes, if environment is going to be the driving force for technology development in the world, which it is going to be, this will come one day. Because when we talk of life cycle analysis in products, I think I can count on my fingers. There are about 16 products actually who have done proper life cycle analysis, and then they actually get an eco mark. If we know what an eco mark is in our country, it's an earthen pot. It's very difficult to get an earthen pot mark on a product which actually talks about a proper life cycle analysis. Life cycle thinking at this stage, I think, should be good enough.
Thank you. Please.
So I'm Rakesh. I'm a PhD scholar and student at IIT Madras. So my question is to Mr. Gert. Sir, I'm working on propellers and developing a code for using boundary element method. So it's very heartening to see your presentation where you have used BEM to optimize the propulsion efficiency of the vessel. So my question is, using BEM, is it the propeller and the appendages being modeled, or is it the full ship being modeled in boundary element method?
What we use today with the current propeller designs is that we use the whole vessel. And today's computer power is strong enough to do that. So we use the full 3D hull, we use the full 3D propeller shape, and also appendages if they are there. So everything is taken into account. And the big difference with the past is that in the past, a hull designer made the perfect hull, the propeller designer made the perfect propeller, and then the two were simply combined, which will not give the best total propulsion efficiency. So today we are able to combine those things and to tune them towards each other. And everything we have, all the data we have, we can take into account in our systems. So this is a big step ahead. And also we, as a company, we are convinced that the traditional model testing is becoming very fast something of the past. Because today CFD calculations are so strong, and also trust in CFD is growing. It's a matter of getting the trust, and we are continuously working on validation of CFD against model test, the full scale, and it's a matter of several years before the industry will change to fully CFD.
Thank you. Thank you.
One associated question, please. You talked of the pre-swirl stator to improve the efficiency. The question is, could this be a general remedy in all cases, or is it on a very specific case basis?
I'm not sure if I get the question right, but what we achieve here is case by case.
Yes, that's it.
And of course, it could be that a vessel is very close to optimum, or that it's not worth the investment. But that's something that we discuss with our clients. But particularly if you look at vessels that has been designed 20 years ago, often there are quite some big improvements to be made. And then it's a matter of having a look at the investment, the return on investment, and of course the plans for the future of that particular vessel. Does that answer your question?
I think so. I think you mean it is a retrofit, possibly?
Yes.
Yeah, thank you.
Thank you so much. I think because we are exceeding students, right? I'll give you one more preference to students backside. Yes, please. That's the last question. Yes.
Good morning. I am Midshipman Ashutosh Rastogi, 7th semester student of Department of Ship Technology. Sir, my question is to Professor Krishnakutty, sir. Sir, in your tuna fish analogy, you showed us that the out part of the ship was actually moving, which will obviously lead to the more resistance in that side. Obviously, also the waves generated by that shoulder part, when interact with the ocean waves as well as the bow waves, will lead to the degree of drop in the degree of sea keeping. So, sir, what are can be the measures for a better sea keeping of this vessel?
That's question to whom actually?
Professor Krishnakutty, sir.
Then the question was, can you explain that a bit more actually? It's not clear for us.
In that, sir, tuna fish analogy of the vessel which you showed us, sir, the aft part of the ship was actually moving to and fro, which will lead to, sir, production of waves, which when interact with the bow waves and the ocean waves will lead to a degree of, which is a decrement of the sea keeping. So what can be the measures to increase the sea keeping of this type of vessels, sir?
Yeah, if I understand the question properly, I think what do you mean by this? Because there is a tuna-like fin propulsion system which is given at the aft of the ship. If when it's oscillating, will it affect the motions of the ship, right? So that's the question, right? Of course, see, this is going to be a symmetric oscillation, and the symmetry oscillation is expected to give a resultant force along the central line of the ship. So this is not going to induce a moment which will turn the ship or change the direction of the ship. So motion-wise, I don't think it's going to have a negative effect due to this type of propulsion system.
Thank you. That's the last question, right?
Yes,
please introduce yourself.
Sir, I'm Ignace from Department of Ship Technology. Yeah. So you have told about to Krishnakutty sir.
Krishnakutty sir, right?
Krishnakutty sir.
Yes, please. Yeah.
You have told about the fin oscillation mechanism, and wouldn't it induce ship motions like heaving in the ship?
Well, say here the one which we have said it's which oscillates in the vertical plane. I mean, I'm saying that's the one, the tuna fin, what you have shown. So that is not going to generate a heave force.
Sir, fin oscillation mechanism.
Whereas the last video which I have shown, which is going to have a motion in the up and down, and also having a pitch and heave combined motion, may have a resultant vertical force which can affect the pitch and heave motion, which need to be studied.
What all can we do to control that?
Sorry?
What are the measures that should be adopted to control those motions?
No, that's what I'm saying. So first we have to identify how much is the disturbing force due to the oscillation, and then we have to come up with the corrective step for that.
Thank you, sir.
Thank you so much. Thank you, delegates, for raising great questions. Thank you so much, the panel. Thank you so much, Dr. Abdul Rahim, Dr. Captain Suresh Bhardwaj, Mr. Gert-Jan Koch, Dr. Krishnakutty, Cadet Lavi, Gulia, Cadet Suman, Dutta, and Cadet Abhinav. Thank you so much. It was indeed an excellent session, and we have covered so many aspects of green ship technology. So a lot of things are going to come up in the coming years as well on the green ship technology and the regulatory side. Thank you so much. Thank you so much for coming to Kochi and sharing out the presentations. Thank you.
May I request the speakers to kindly hold on along with the session coordinator, please. After this invigorating session of highly technical and educative papers, it is time to thank and honor the speakers and the session coordinator. For this, may I call upon Mr. Anthony Prince onto the stage, please. Mr. Anthony Prince is the President and CEO of the Smart Engineering and Design Solutions Limited SETS. He has been instrumental in putting India on the world shipbuilding map by bringing the order for 6 30,000 deadweight bulk carriers of Korean design and equipment package to Kochi Shipyard Limited, with which he has been associated since 2004. We will begin this program with distribution of mementos and certificates to the speakers, starting with Dr. Abdul Rahim. May I request Mr. Anthony, please kindly do the honors. Dr. Captain Suresh Bhardwaj, please. Mr. Gert-Jan Van Gogh, please. Abhinav. Midshipman Suman Dutta, please. On behalf of all the three teammates. Professor P. Krishnakoti, please. And of course, a big hand to Mr. Ashik Subhani, who was the session coordinator for the first session. May I now call upon Mr. Sohan Roy to come up on the stage, please. May I request the students and the session coordinator to make way for Mr. Sohan Roy, please. Thank you, speakers. Thank you, the session coordinator. Mr. Sohan Roy is a well-known personality amongst us, a multifaceted personality, a writer, a poet, and a Hollywood film director, the CEO and the founder of the Aries group of companies, a naval architect, and he has his name in the Guinness Book of World Records as well. So, without any further ado, may I now request Mr. Yashwant, the student placement coordinator from Department of Ship Technology, CUSAT, to kindly come on stage. May I now request Mr. Sohan Roy to kindly release the placement brochure and hand over to Mr. Anthony Prince. May I also request Mr. Sohan Roy to release Voyage, the annual newsletter of the Department of Ship Technology, CUSAT, and hand over the same to Mr. Anthony Prince. Thank you, Mr. Sohan Roy. Thank you, Mr. Anthony Prince. With this, ladies and gentlemen, we come to the end of the session 1. We would now proceed for lunch arranged at the foyer. You may note that the food coupons marked lunch 1 and lunch 2 are for today and tomorrow respectively, and the same may be handed over at the food counter. It is requested that the attendees may assemble back at 2:30 after lunch for the session 2 of the seminar on the topic Inland and Coastal Navigation, Transportation. Thank you.